Good day, students. I am Dr. MONIKA KHETARPAL. I am Associate Professor of Physics in Government Dungar College, Bikaner. Today, I will discuss about the London penetration depth. London penetration depth, as I have derived in my previous lectures, it has a value m upon mu 0 ns e square raised to the power half. This London penetration depth was derived by taking a specimen of superconductor and a magnetic field was placed on the surface of this superconductor. Value of the magnetic field we have taken to be equal to V0. Solving the expression, we have derived that magnetic field inside the specimen, which is spread in the X region, magnetic field inside the specimen will have a value Vx is equal to V0 exponential minus x upon lambda. That is, inside the specimen, magnetic field will decay exponentially. And we have already derived the expression of London penetration depth, which is dependent upon temperature. We have found that lambda T upon lambda 0 equal to 1 minus T upon Tc raised to the power 4 raised to the power whole raised to the power minus half. Here Tc is the critical temperature and T is a particular temperature at which lambda has a value equal to lambda T. Lambda 0 is the value of lambda at 0 Kelvin. We have already discussed the formula of density of superconducting electrons. Density of superconducting electrons is Ns is equal to N0 1 minus T upon Tc raised to the power 4. Here N0 is the total concentration of electrons, because in superconductor between 0 to Tc there are two types of electrons, superconducting electrons and normal electrons, and these two concentration, normal and superconducting concentration, add up to give us N0. Now I am going to discuss a numerical which has been in the paper of year 2010 in MGSU University. Numerical is the penetration depth for lead for 396 R396 angstrom and 173 angstrom at 3 Kelvin and 7.1 Kelvin. We have to find out the critical temperature for lead. That means we are given the value of lambda for two temperatures. Temperatures are also known, and we have to determine the value of Tc. Since I have already given the formula of lambda, which is dependent on temperature, using this expression, I have used this expression lambda at a particular temperature T upon lambda 0 equal to 1 minus T upon Tc raised to power 4 whole raised to the power minus half. Putting the value of lambda, which in the numerical is given 396 and the temperature is given 3 Kelvin. Hence putting T to be equal to 3. Using the first condition, similarly by using the another condition, I got the expression. Now since Tc is unknown to us and lambda 0 is also not known to us, by dividing these two expressions, lambda 0 will cancel out and we are left only with the one unknown parameter, that is Tc. This is depicted in this expression. Solving this expression, I got the final solution Tc equal to 7.12 Kelvin. Hence, we have determined the unknown parameter, which was the critical temperature to be determined. Now I am going to discuss another problem. In this numerical, we have to determine the penetration depth for a superconducting material which is having 4 into 10 raised to the power 26 electron per meter cube. And we have, in this numerical, we have to also find the physical significance at critical temperature. This is the numerical of 2018 of MGSU University paper. In this expression, the unknown parameter is lambda, L, London penetration depth. What we are given in this numerical is the number of electrons, that means density is given, N is known to us. Since we know the formula of lambda has m upon mu 0 Ne square whole raised to the power half. Mass of electrons is known to us, which is equal to 9.1 into 10 raised to power minus 31 kilogram. Charge, E is the charge of electron, which we all know that it has a value 1.6 into 10 raised to power minus 19 coulomb. Mu 0 is permeability of free space, which is given to us 12.56 into 10 raised to power minus 7. And it is given in the question 4 into 10 raised to power 26. Hence, putting all these known values, we can easily calculate the value of lambda. Here I have determined the value of lambda 265.9 into 10 to the power 9 meter. Now I have to determine the significance of London penetration depth at T equal to Tc. For this purpose, I have used the expression lambda equal to lambda 0 1 minus T upon Tc raised to power 4, this whole raised to power minus half. Temperature is given T equal to Tc, putting the value of T to be equal to Tc. Putting this T equal to Tc, I got here 1 minus 1, which is 0, and I got lambda to be equal to infinite. Hence, London penetration depth when T equal to Tc, this has a value infinity. This has a physical significance that at T equal to Tc, magnetic field penetrate inside the specimen. That means material is not superconductor now. It is behaving as a normal material as T has approached to be Tc. Hence, we can conclude that we can also verify the parameter that T equal to Tc divides the superconductor into two ranges. So below Tc, the material is superconductor, and above Tc, the material will behave as normal material. These numericals are very important. I hope you must have understood what I taught you today, and hope that you may be doing another numericals of similar type which are based on London penetration depth determination and the determination of density of superconducting electrons. Thank you, students.